Charlie, my father's placed me on restriction until I get my algebra grade up. That means I can go to the movies with you Friday night.
What time does he go to bed?
10 o'clock. But I have to walk past his bedroom to get out of the house and he'll hear me for sure.
Can you sneak out the window?
My bedroom's on the second floor.
How high above the ground is the window?
When my father painted the house last year, he measured. He said it was 15 feet.
Leave it to me, Rhonda. I'll figure something out.
Charlie, is that you?
I climbed the ladder.
Is it safe for me to go down?
Of course it's safe. I figured it out using the Pythagorean theorem.
You mean that old formula is good for something in real life?
Yes, the right angle is formed by the house and the ground. Your window is 15 feet high and the foot of the ladder had to be 8 feet from the base of the house for safety. The 8-foot distance from the house is one leg. The 15-foot distance to your window is the second leg. The ladder is the hypotenuse. I substituted into a squared plus b squared equals c squared. 8 squared plus 15 squared equals 64 plus 225 equals 289. Since the square root of 289 is 17, I knew a 17-foot ladder would get us out the window and down to the ground safely.
Today, we are talking about the Pythagorean theorem. What can you use the Pythagorean theorem for, Rhonda?
You can use it to figure out how long of a ladder you need to reach a window.
And what is the formula for the Pythagorean theorem, Charlie?
Thus, Mr. Snively, it's a squared plus b squared equals c squared.
And when might you use the Pythagorean theorem in real life?
I'm not sure, sir.
Well, let's discuss some examples. Please come to the board and explain the problem, Rhonda. Remember that the ladder is 8 feet from the base of the house and the window is 15 feet above the ground.
Well, let a equals 8 and b equals 15. Substitute into the formula and square each term. 8 squared plus 15 squared equals 64 plus 225 equals 289. The square root of 289 is 17.
Thank you, Rhonda. Now here's an example for you, Tiffany.
In this problem, we are given the hypotenuse, C, and one leg that I will call B. We can substitute and solve for A. A squared plus 12 squared equals 13 squared. Squaring gives us A squared plus 144 equals 169. Subtracting 144 from both sides gives us A squared equals 25 or A equals 5.
Thank you, Tiffany. Now it's your turn, Eric.
In this problem, we use the Pythagorean theorem twice. First, we find the length of CE in triangle CDE. Then we use that result to find the length of BC. In the first triangle, 3 squared plus 5 squared equals 9 plus 25 equals 34. CE is the square root of 34. BE is also the square root of 34. Substituting into the Pythagorean theorem gives the square root of 34 squared plus the square root of 34 squared equals 68, which is c squared. Taking the square root of 68 gives us 2 times the square root of 17. The square root of 68 reduces to 2 times the square root of 17.
Thank you, Eric. Charlie, it's your turn again.
This problem requires reading a graph. The horizontal line, AB, is 3 units long. The vertical line ADC is 4 units long. Those are the legs. This gives us 3 squared plus 4 squared equals 9 plus 16 equals 25. Taking the square root gives us BC equals 5.
Rhonda, please explain the problem to us.
We can tell by reading the diagram that AB equals 6 and BC equals 8. That gives us 6 squared plus 8 squared equals c squared. 36 plus 64 equals 100. Taking the square root gives 10.
Now do problem 2, Tiffany.
The answer is 24. First, find the hypotenuse of triangle ABC. Since the legs are 6 and 8, the hypotenuse must be 10. Now look at triangle CBE. We know the hypotenuse is 26 and one leg is 10. Substituting into the Pythagorean theorem gives us 10 squared plus b squared equals 26 squared. Squaring gives 100 plus b squared equals 676. Subtracting 100 gives b squared equals 576. Taking the square root of both sides gives b equals 24.
Thank you, Tiffany. Excellent as always. Eric, you're next.
The answer is 12. Use the Pythagorean theorem twice. First, find the hypotenuse of triangle BCE. Since the legs are 3 and 4, the hypotenuse must be 5. Now find the leg of triangle ABE. The leg is 5 while the hypotenuse is 13. Substituting into the Pythagorean theorem gives us 5 squared plus b squared equals 13 squared. That gives 25 plus b squared equals 169. Subtract 25 from both sides. We get b squared equals 144. Take the square root and get b equals 12.
Excellent job in solving a multi-step problem, Eric. Charlie, it looks like we're back to you. Charlie's mom is really mad at him and chases him around the corner of the house. When he is 15 feet from the corner on one side and she is 8 feet from the corner on the other side, how far apart are they?
They are 17 feet apart. Substituting into a squared plus b squared equals c squared gives 8 squared plus 15 squared equals c squared. We get 64 plus 225 equals c squared. 64 plus 225 equals 289. Taking the square root of both sides gives c equals 17.
Thank you, Charlie. Rhonda, you're next. This problem is easy if you know that ABC is a right triangle. But how do we know that?
We know it's a right triangle because the two radii are both 5 and since one base angle equals 45, the other must be 45 too because it's an isosceles triangle. We substitute into a squared plus b squared equals c squared. We get 5 squared plus 5 squared equals c squared or 25 plus 25 equals c squared. This is 50 equals c squared. Taking the square root of both sides gives us the square root of 50 equals c. This simplifies to 5 square root of 2.
Thank you, Rhonda. Tiffany, would you like to try another problem?
The answer is 3 square root of 2. The hypotenuse is 6. The legs are the same length. Let's call them x. Substituting into the Pythagorean theorem gives x squared plus x squared equals 6 squared or 2x squared equals 36. Divide by 2. We have x squared equals 18. Take the square root of both sides. We get x equals the square root of 18 which is the square root of 9 times the square root of 2 or 3 square root of 2.
Eric, it's your turn. How do you know this is a Pythagorean theorem problem?
This diagram illustrates the right angle formed by two cars, one heading due north and the other heading due east. The dotted line is the distance between them. The distance traveled by each car is a leg of a right triangle. In this problem, we have 12 squared plus 16 squared equals c squared. Thus, 144 plus 256 equals c squared. 400 equals c squared and c equals 20.
You did a nice job illustrating the situation with the diagram. Charlie, I think I want to call on you again.
This is a hard one, Mr. Snively.
Here is a hint. If the kite is 15 feet above the ground, but the string is in the girl's hand, which is 5 feet above the ground, how far above the girl's hand is the kite?
10 feet, sir.
Then what are the dimensions of the right triangle you are working with?
Since the kite is 15 feet high and her hand is 5 feet high, the leg is 10. The other leg is 20 because the horizontal distance between the girl and the kite is 20. This is my solution. A equals 10 and B equals 20. Substituting into the Pythagorean theorem gives 100 plus 400 equals 500. Taking the square root gives 10 square root of 5.
Charlie, I'm impressed.